So let us have a look at each one of them. So firstly we'll study about this range. So what is range? This is first of all simplest of all, and it is defined by the difference between the largest quantity and the smallest quantity. So L represents here the largest value of the given data, S represents the smallest value of the data, and this is the absolute measure of dispersion. That means suppose your data is given to be, say, weight of persons. So suppose one person is having weight 50, one is having 45, one is having 60, 65, and then 70, 72, and say 90. So this is the given data. So this has units in kg. So range would be defined by the maximum here is L would be 90, and the minimum here S, that is given to be 45. So range here would be L minus S. So that would be 90 minus 45. So we have 45 here. So this is 45 kg. So this has the same units as that of the given series. So therefore this is known as absolute measure of dispersion. Next, another term corresponding to this range is the coefficient of range. So what is this coefficient of range? It is defined by L minus L divided by L plus S. So now this is the relative measure of dispersion. Why? Because L minus S, its units will be kg. L plus S, its units will again be kg. So this kg units will cancel with kg units. So this quantity would be unitless or dimensionless. So this will give you a relative measure, dimensionless. So that is why we say this is the relative measure of dispersion for this particular range. So we have two formulas. One is this, range is equal to L minus S, and another formula is coefficient of range, that is given by L minus S divided by L plus S. So this is very simple. So let us see the next example now. The example says we have 5 students whose marks in statistics are 20, 35, 25, 30 and 15. So we are to ask find the range and the coefficient of range. So now what kind of series is this? This is individual series or the raw data that is given to you. So now here what would be L? L would be the largest value. So the largest value is this one, 35, right? And the smallest value is this 15. So what would be the range? The range would be 35 minus 15, that is 20. And the corresponding coefficient of range, what is that? That is L minus S, that is 35 minus 15 divided by 35 plus 15, that is 20 by 50, that is 0.4. So next we will have another question. This says we are given some marks and the number of students having these marks. So marks are defined from 10, 20, 30, 40, 50 and 50, 60 and 70, and the number of students having 10 marks is 15, 20 marks is 18, 30 marks is 25 and so on. So now first thing, what kind of data is this? This is the discrete series. So that means you have the x values here and you have the frequency given here. So that is given to you. Now you are asked find the range and the coefficient of range for the following data. So this is asked to you here. Here the range is largest value minus the smallest value. So this is given to be 60, and the coefficient of range, that is given to be L minus S divided by L plus S. So this is, when you calculate, this comes out to be 0.75. And what would be the range and coefficient when your series is continuous type series? So that means you are now given class intervals. So here you see we have 20 to 29, then 30 to 39, 40 to 49, 50 to 59, 60 to 69. Now this is an inclusive series. What do you mean by inclusive series? That means the range is not continuous. From 29 we directly move to 30. Whereas for continuous we need either from 30 to 30 or we need either from 29 to 29. So that means this last value here, that means 29, and this first value here, they should be same for continuous or exclusive series. So the first task is, before calculating the range, is to convert this inclusive series into the corresponding exclusive series. So how can we do that? We can just we first see what is the difference between 29 and 30, that is 1. So 30 minus 29, that is 1. So we divide this by 2, so we have 0.5. So what we do, we just add the 0.5 here and subtract 0.5 to the lower limit. So when we subtract 0.5 from 20, we have 19.5, and when you add 29 to 0.5 to 29, you have 29.5. And similarly for the next intervals, when you subtract 30, you have 29.5, subtract 40, you have 39.5, and so on. So these intervals are obtained by subtracting 0.5, and these intervals are obtained, these upper values, they are obtained by adding 0.5 to the given data, right? So this is the class interval that we got, and the number of students representing the frequency would come as such. So now the range would be the largest value, that would be 69.5, this value, and the smallest value would be 19.5. So the subtraction of these two would be the range. So our range is 50. And the coefficient of range, that would be L minus S divided by L plus S. So that is 0.562. So now let us see what are the merits and demerits of range. The merits are, it is very simple to understand, it is very easy to calculate the range, and it is widely used in statistical quality control. Whereas the demerits are that it cannot be used for open-ended intervals. It is not based on all the observations. Why? Because we only use the lowest and the highest values to calculate this range. It is affected by sampling fluctuation. So because if you this means that if you change the sample, if you change the data, so your range would change. Next is, it is also affected by extreme changes in extreme value, because we only use the extreme values in the calculation of range, the lowest and the highest value. So that is why it is not a reliable measure of dispersion.